And people will keep coming through this door. I'll try to take it slow. At the same time, we have a rather packed agenda for today. We will not be doing some activities to don't bore you to death. We will only do fun stuff tonight. What's interesting? What's interesting? Interesting is that we have a full room and people keep coming. That is, I think, pretty amazing. For home, this is the first time here. 1, 2, half. Okay, maybe a little bit less than half. Cool, great. What else? First of all, today we have two main speakers, both of them experts in their own field. I have no doubt about that. So they will introduce themselves by themselves. They are definitely capable of doing that. Then we will have a little surprise for you in the middle. Then we'll have another surprise for you, and then there's gonna be some snacks, some drinks, to some refreshments, and then we'll continue with more surprises and more talks and evening fun for us. Let's get to it. So a little bit of agenda. Already we talked about that. You can expect that you'll get out to get some pizza around 8:20, 8:30. Yeah, if you're super hungry right now, then squeeze it together. There's no solution for that. I'm sorry. Yeah. Okay. Moving on. So first of all, let's give a big applause to our general partner, Armato. They are hiding here tonight as well. It's a new thing. Those who are following our feed, then this was signed in December. So this basically is the first event with them as general partner. What does it mean is that you will keep seeing this logo throughout 2025. Happy New Year. Then definitely, as always, big thanks to Workland and to Andre, who connected us with Workland, who is always here, who is not just helping with Workland, but also often helping behind the computer on the live stream. Thank you, Andre. And then, do we have people from Mogotel here? Two Lauras.
No, one Laura I can say it's not here because I'm not.
Yeah, there should be two Lauras coming from Mogotel. They are not, I think they're not IT, but they do want to see what the event is about. They are hospitalizing, no, they are hospitality sponsor, and Stefano is staying with them. How's the hotel?
Amazing.
Great. Cool. It's not just Latvian hotel, they're actually global. It's a pretty big hotel business these days. So we love Mogotel, Mogotel loves us, we move on. What else? Does it work? I broke it, I'm sorry. Because I don't know how to use it. So that's us. I keep, yeah. Thanks to the team, I think that the biggest applause goes to Vilmars tonight. I hope he is watching online. It's a personal thing, but who cares about personal stuff, right? So he just became a father, so that's amazing. Yeah. Then the very first icebreaker. We are bringing back these things because we are here also about the connecting, not just about gaining knowledge and stuff, right? So the rules are super simple. Find someone who you don't know, tell your name, and what do you do? You're a pair, right? Just find someone you don't know or you haven't seen in a really long time. And then to that person, after you have made your intros, quickly tell one positive thing to that person about your first impression about each other. And at the end, before you're like, bye, try to remember each other's names and think. I'll give you literally 1 minute for that. Go now. Okay. Thank you. Do you know each other's names? Yes? Yeah. Because I'm always like that. Hello, I'm Lucas. I'm like, what did that person just say? I believe it's for many people like that. Okay, thank you. We move on. So, the organizers who are not ashamed to show their names, because we have a few companies hiding on this slide. So first of all, since the very beginning, I'd say we have Evolution. Marx is over there. So these are the company names behind those faces on the other slide. Then Zenis, that's me, Will and Wilmars. And then we have JK Technologies. Where are you? JK Technologies. Yeah. Then community goals. So why we are here? First of all, the event is for free. I hope you didn't pay anyone. Yeah? Okay. We're here about socialization and networking. Our goals are to grow the community. We want to share the knowledge. We want happier DevOps specialists and better AI practitioners. That's what DevOps and AI Latvia is about. Then we move on. You somehow got here, so most probably through one of these channels. So I hope you know what those are about. Then if you're interested to join me here on the stage some other day, by the way, it's not like I'm taking care of all events. Today you just kind of are stuck with me, and Edgars will show up at some point once he has checked in everyone. So DevOps LV, no AI here. Sorry for that. But you can find the speaker form there. Then for those who are right now representing some big companies, I'm looking over there to that guy. Now you need to guess which one was that. We have 3 types of approaches how you can become the sponsors. The 1-year general partner, you saw that. Then there's an option to become a sponsor for one event and do some additional stuff at the event, kind of go big. And then a smaller thing, 1 event sponsor, maximum is 2 per event, just to get your name out there. And then going back to, it seems like I need to check what's on the next slide. Yeah, it's not quiz time. And we'll get to the very first presentation. The Stefano, you can try to set up. I'll try to make come. I'll try to entertain others while you are setting up. I should remove this somewhere, yeah? You take this. I move this.
And microphone.
And microphone, I promise.
You on YouTube?
Amazing.
You on YouTube?
Okay.
Can you make it up?
Thank you. Okay.
Ready?
1 second. Okay, ready. So thanks a lot. Thanks a lot, Uldis, for this invitation. And thank you everybody for joining me today. I am very excited to be here. I am from Tallinn, so I just came for you. And today we're gonna talk about some interesting stuff. We're gonna talk about AI. So many presentations today start with AI, but also about some bad stuff. Okay, incidents. And when we talk about incidents, we think about something that shouldn't happen. I really like this quote that says, it takes 20 years to build a reputation and just a few minutes of an incident to ruin it. That's pretty bad. And maybe somebody of you already handled an incident in the past week. Raise your hand. Cool. So probably some of you know this feeling. But before we get started, actually, we do have a bit of quiz time. So I would like you to take out your phone and scan the QR code.
It's safe.
It is safe. It is safe. You can trust me. So in this screen, you should be able to enter your nickname. Does it work?
Yeah. No.
There's only one button.
Yes.
Okay, so that's cool. Now I'm gonna start it very soon. So stay with me. So incidents are bad, but they happen, and we know they are important, but still they happen. So I want to test your knowledge. Doesn't work. Give me 1 second. So I'm gonna do this. Okay, now it should work. I see 39 players ready. I'm gonna move the screen here. Okay, I will not share the screen, but you can see it on your phone, right? Yes. Amazing. So let's start with a very quick question. Let's test a bit your knowledge. So answer fast to get more points. What was the approximately the financial damage of the largest incident last year? So it can be from 100 to 500 million USD, from 5 to 10, or more than 10 billion US dollars. Okay, the answer was $10 billion. 16 of you got it right, but don't worry, because we have more questions. Right now, I see that T-Book is the first. Who is T-Book? Raise your hand. Nice. From the back with a beer. Let's go to the second question. So how many machines were directly impacted by that incident? Directly, because the impact is much bigger than that. So 8 million, 5 million, 10 million, or 100 million. So direct impact of the incident of 2024. Still 2 seconds. Okay, it was actually 8 million approximately. Direct impact. Okay. Let's see how many of you got it right.
we don't have the leaderboard now, but we have the last question for this part of the presentation. What was the effect of operating system? This one should be easy, I hope. So Microsoft Windows, Linux, or Red Hat Linux, or CentOS. Everybody has voted. Be careful with your votes. Okay. That was Windows, obviously. So little icebreaker. We're gonna have the next question later. But maybe somebody knows which incident I'm talking about.
CrowdStrike.
Yes, correct. That was easy. With that said, let's start our presentation because we know that incidents are important. We invest a lot of time, a lot of resources into handling them, but maybe there are better ways of how we manage incidents. Before we start, little presentation about me. I work as a staff software engineer at a scale-up based in France. It's a FinTech scale-up. We are more than 3,000 employees, valued more than 5 billion euros. Although this project that I will present with you is not related to the company I work for, it's more a side project that I do the open source community. I'm also founding lead of OWASP Tallinn, an early contributor of OWASP Top 10 for large language models. Raise your hand if you know it. Not many, okay. So just to check it out, it's a new initiative by OWASP where we provide insights on the vulnerabilities for large language models. So let's begin. On today's menu, we're going to have a very quick introduction on incident management for those of you who are not familiar with it. Then we will have an introduction of predictive incident management, this new approach that we're going to discuss it now. And then a little overview, an architectural overview of a predictive incident management system. That's the project I've been working on, and I welcome your feedback on it. At the end, we're going to have a final quiz as well. I don't have prize, but the prize is the fame. Okay. So what is an incident? Raise your hand. Very simple definition. Quick question. Somebody wants to answer. What is an incident? In one sentence. Please.
Everything gets ready.
Yes. Yes, we can say that. And we can say that everything gets wrecked. And we didn't expect that. Okay. So it's a disruptive event that causes some financial and operational harm and losses that can be substantial. So in the case of CrowdStrike, for example, they lost several billions directly on the stock price, but much more on liability. Okay. There are different types of incidents. So incident is a very broad term. So we can talk about cyber incidents, malware attack, data breaches, phishing, a lot of different types of cyber incidents inside this category. But then there are also technical incidents. So let's say a developer releases a new deployment that breaks your system. These are commonly referred as technical incidents or operational incidents. And they can also be very harmful. So when we talk about cyber incidents, usually we get the feeling that they are more serious, but that's not the case. For example, what we saw with CrowdStrike, they've been there and done that because that's exactly the kind of incident that they faced last year. It was a technical incident. It was a wrong deployment of a buggy software. In this speech and architecture we're going to have a look at, we focus only on technical and operational incidents. However, the same concept can be applied in cyber incidents as well. So I challenge you to try out these concepts in other scenarios. So how do we usually manage incidents? The most common approach is reactive incident management. So whenever we face an issue, whenever we monitor and we get an alert, we stop and fix. This is the stop and fix approach. And we aim at resolving and mitigating the issue as soon as possible. So if we were to give a very quick introduction of how the process works, is that we have some monitoring set in place if we do everything correctly. And we get an alert that something went wrong. we classify the incident if it is an incident or if it's a false positive, and we prioritize based on the impact that the incident has. And then obviously, once we realize it is an incident, and it has an impact, then we need to act on it and mitigate it. If we look at the standards around this process, there are different ways of different frameworks to standardize this process. One is NIST, and the other one is ITIL. So if we go in a bit more detail of this process, we have incident identification. So here I put some example of tools that we use, for example, to monitor our systems, Prometheus, Grafana, maybe Sentry on the front end or back end. Then we have incident logging. So this is also for more compliance perspective. So we need that an incident happened. We categorize it, we prioritize it, and we respond to it. Okay, these are the principles of reactive incident management. But what if I told you that we can actually resolve incidents before they even happen? Welcome to predictive incident management. So this is what we aim to do with predictive incident management. If we were to simplify the approach, it follows completely different idea of reactive incident management, where we have monitoring. So we capture data continuously, as we already do. But then we have predictive observability. So we forecast the risk of an incident and we act before it even happens. This is what we call prevention or automatic remediation. So what are the goals? If we were to implement this approach in a system, so in an automated way, what are the goals that we want from this kind of systems? We want to forecast problems before they happen. That's the main goal. But one important thing is that this system needs to learn and act based on our previous incidents. That's one important point. It needs to be able to understand what went wrong previously, because obviously in the beginning, we cannot predict everything without data. So this system specifically is very efficient if we have some data to train it on, that it can learn from. So usually in incidents, it's important to mitigate them, to resolve them as soon as possible, but also to understand what was the root cause and get an understanding of what went wrong and not to repeat it again. With predictive incident system, this incident management system, this becomes automated, okay? And also, I put this last point. So with this kind of systems, we aim at reaching a zero incident system. So this is theoretical, right? I never experienced or saw or even imagine a system that is fully aiming at a zero incident policy. But theoretically speaking, this can bring, this kind of approach can bring this to reality, okay, this concept to reality. So now what I would like to show you is an architecture of a predictive incident management system and how the different components work together. So we can go a little bit more into the details of how it works. So let's start with what data we need. What data we need to ingest in this system. The basics, of course, is the system logs, so the elk stack, for example, some metrics. Then we have commits. These are important because we focus on technical incidents. So let's say a developer commits something, somehow it gets reviewed, gets approved, gets merged. There's a potential indication that something might go wrong. So this data specifically is important in our case. But then we have another point that are user reports. So let's say we have a Jira or a ticketing system. This architecture I will show you is particularly effective at ingesting user reports because they are in natural language. And then we might also have API logs or sentry issues as the normal systems that you might already have. And then what happens? So we aggregate this data on a continuous basis. So it's something that continuously aggregates this data. And then the core of this system is Vertex AI. Small disclaimer, I use Vertex AI, but you can use any kind of large language model. It's not linked to Google or a specific model. I just use it because I find it more powerful, and we'll go into more details about that as well. So why Vertex AI? I really like the performance of Gemini 2.0. And even if you use Gemini 1.5 Pro, it has a context window that is huge, it's 2 million tokens. And that's particularly useful when we want to give more context to LLM using RAG. So who knows RAG? Cool. Very quick definition of RAG. Somebody wants to volunteer?
Yeah, retrieval augmented.
You.
And that stands for retrieval augmented generation, basically any methods of adding additional context into the LLM, usually done on similarity search, but also keyword search or whatever else suites does.
Exactly, yeah, you're completely correct. So basically it's a way to augmenting the prompt with additional information, and the goal is to make the LLM more specific to your use case without fine-tuning it, if we can frame it this way. Exactly, and it's much more cost efficient and easy to set up than fine-tuning a model, for example, or retraining it. And especially in Vertex AI, there is this RAG engine that makes the process very quick and easy. And yeah, so that's why I use it. But again, you can, the con part of it that is, it brings a cost, right? So it's costly, especially if you deal with large amounts of data. But wait, so some of you, probably the most advanced people here, are wondering why we're using large language models for this system. There are other AI and other approaches that we can use to model the risk of an incident. And that's what existing predictive systems use. For example, Bayesian networks, that's the most common one, that's the most powerful one. They model the risk not only of incidents, but also about, for example, financial risk, market risk, operational risk. They are very good at modeling risk in general, and also incidents. The reason why, yeah, for example, they also put this fun infographic. So the way it works, for example, if season is raining and the dog is barking, then the cat will hide. That's a very simple representation of how these networks work. Now it gets much more complicated than that, but they are very effective at finding the relationship and modeling risk. So why then large language models? That seems very weird, right? Very unrelated. And it's an hot take. This is an experiment I'm doing. There are many people who will find it weird or wrong, and that's completely fine. But the pro of using large language models is that they can understand and they can parse unstructured text like logs, tickets, and alerts very easily. Instead, in other approaches, we need to really filter the data and prepare it for the model to be consumed. And this is a process that in itself is very costly, both from an economical perspective, but also time-wise. With a large language model, you can spin up this system and make it run very quickly. Also, the cool thing about large language model is that you can play with it, and theoretically you can build a chatbot that has the information about all your incidents, all your data, and you can chat with it. So you can investigate, it was like it is an expert around your incidents data. Another thing is that they adapt very quickly to new patterns. So you can add a new data source very quickly. You don't need to clean up the data and do feature engineering once again. And overall, they're very easy to set up and run. So then why not? There are, of course, limitations. They are not the best fit for this specific case, but they perform well according to my benchmarks. Then there are also context limitation. So we have a limit to how much information we can share with the model. But for example, in Gemini 1.5 Pro, the context is pretty high. Okay, it's pretty big. So rarely you would hit that bar. Also can be costly if you run on clouds. And yeah, in general, there might be more better suited approaches to this problem. So let's continue our architectural view. So we have the data collection at the top, then we have the large language model that will be able to predict when something is about to go wrong. And not only, here we have an important step, that is prevention. Now we have different approaches to this system. It can alert us when something might be breaking, but it can also prevent it from happening altogether. So we remove the human in the loop element and the AI becomes fully autonomous. Now, if we have prevention, automatic prevention or automatic remediation, that means that we are fully confident on the accuracy of the model. And that's something that is not easy to achieve, but again, it's something that theoretically is possible. And then one important thing is that whenever we have more incidents, more data, we have pipelines that fully augment the data that we ingest in the LLM, and we monitor and feedback all this process to make sure it's currently working. Yeah, so some cool aspects of these systems is that they are easy to interact in natural language, they are easily scalable with unstructured data as we spoke, and it's easy to test scenarios. Like we can try on a mock environment if we would be able to understand if the incident is about to happen or not. That's very easy to mock up, and that's very easy to modify and scale. And we have the theoretical possibility of automatic remediation, as I was speaking before. In general, we could see this kind of systems as an ambient agent. Agents are huge right now in AI. An ambient agent, somebody heard of this term? It's pretty new. Yeah. Somebody wants to say something about it? What is an ambient agent, according to what you heard?
No, I don't want to say anything, just...
Okay. Okay. But yeah, basically, ambient agent is an AI that you don't prompt, but knows when to act based on the things that is observing. So in this case, we could see that this system could be considered an ambient agent. And that's very cool. That's the direction I've seen many companies are going for. For example, LangChain founder, I think just a few days ago, 1 week ago actually, published this article that seems to be ambient agents to be the future. And so predictive incident management system as we saw could be part of this wave. Okay. To end this presentation, I would like to continue. Yes, this is a definition of ambient agents. So AI systems that run in the background, continuously monitoring event streams, and they act when they think is appropriate. But to end this presentation, I suggest we continue the quiz. There are 3 last questions. I hope you are still into the quiz. If not, let me know if it doesn't work. This time, we might hit the limit actually of people who can answer. If you hit, you can do it with your friend next to you. Is everybody in? Cool. Okay, let's see who is first. The faster you answer, the more points you get. Huh? So we have Simba first. Who is Simba? Okay, nice. Let's see. Yeah?
Can you remove the QR code?
You got kicked out? Okay, let me see. Wait. Okay. Works? Okay, let's go. So how do organizations typically measure the success of AI in predictive incident management? That's something we didn't talk about, so make your guess. So we have number of manual solved incidents, reduction of mean time to resolution, or number of alerts generated by the system. Actually, this is interesting because right now we are focusing on reduction of mean time to resolution. So it means that the companies are using AI in a different way compared to what we saw now. They're using AI as a way to assist them to fix the incidents as they happen. Okay, so that's a big innovation that we are bringing if we apply the concepts that we saw today. Simba is still first. But we still have some follow-up, some runners. So let's see the next question. So what percentage of companies said that AI significantly improved their incident response times? So companies are using AI in different ways, their incident management procedures. So we have 37%, 47%, or 75%. Actually, 75. That's a lot. And you will be surprised because, for example, Google, they publish an article on their blog, and the way they're using it is just to summarize the incident and make it like creating the report with Gen AI. So that's a very simple use case, but already that improves a lot the process and the lead time of the process. Okay, Simba might not be the first anymore, fortunately. Yes, for a few points. Bell, who is Bell? Nice.
I'm sorry, I didn't change the name. I go old phone.
Now we have the last question. So how does AI improve root cause analysis in incident management? So by automating the RCA process, by focusing on real-time data, or by eliminating the need of historical data. It's a bit, both of them, like all answers are correct, but one more than the others. Well, not this one for sure. By automating the RCI process. So in a way, it helps us by understanding things automatically rather than us manually analyzing everything. Let's see who is the winner. And I think it's gonna be Bell, just for a few points. So congratulations, Bell. Okay, and this last question was important because not this screen. All right. Because I really like this quote by Robert Kiyosaki, is the author of Rich Dad Poor Dad, amazing book, not tech-oriented book. He says that the best way to predict the future is to study the past. But what if the best way to predict the future is to have AI study the past for you? This is a quote by me. With that, I thank you. And this was an experiment that I'm doing as an open source project. So if you are interested in learning more, contributing to it, feel free to connect with me on LinkedIn. Thank you. And if you have some questions, actually, now maybe we have time for this. Okay.
Yes, we do.
Cool. Please.
What's the end-to-end latency of it?
That's okay. That's a good question. Right now, it's not something that is in production, so it's not a limiting factor. But that could be one of the things that could limit the feasibility of it. I don't see latency as an issue because it's not something that we aim to predict an incident a few seconds before it happens.
Sure, but if you have a high latency with an aggregation and processing, and you have 2,000 things to aggregate and process, you have a bottleneck.
It is a bottleneck, yes, that's a good point. But the best way this system works, like the best case scenario, is, for example, let's say commits. Commits is the most classic example. And there, we can delay a deployment by 10 seconds, right? If we have a pipeline that lasts 30 minutes, mine lasts 15 minutes, for example. We can delay with a 15 seconds latency. If we are monitoring system logs and we aim to prevent that kind of incidents that we want to prevent a few seconds before, then it plays a role. But if we focus on event-driven data, like commits, for example, I don't see how that could be a bottleneck.
But follow-up question: if it's
Yes.
event-driven data, what's the benefit of an LLM versus a deterministic model?
So yeah, that's another good point. So for example, how would you use a deterministic model?
Anomaly detection.
Yeah, that's an option. But the point is, it's never, you can test it. You can test if the LLM is more performant than anomaly detection, but it's not necessarily the case though. Yeah, I see your point, and that's why this is kind of a new approach, and it's something that we're testing out, and it's not necessarily the right tool for the job, but it's worth investigating, in my opinion. Yes, please.
Yeah, thank you. About the commits. So, for example, in the case of commits, AI, for example, detects that this change might break
Yes.
production. Would it prevent like deployment, or how does it proactively prevents the incidents?
In my view, it would prevent deployment, and it would require human intervention and another review, for example. So it would detect that something might break and would alert us before deployment. So it would actually prevent the incident in this way.
I have one more follow-up. And
Yes.
for example, if AI detects, like, for example, space is filling up, would it be possible for it to, for example, issue the changes in configuration by itself?
Yeah. I mean, that's possible. We are not quite there yet, but theoretically, yes, that's the idea of it. Yeah, that's the potential that it has. Automatic remediation. Please.
So my question is, it's hard for me to imagine that this thing would be deployed or some small project like for 12 people. So we are talking more of a bigger deployment, like 200 people team, because probably at the first stages you will have some dedicated people setting this thing up. And with these big teams, big deployments comes the port of data, especially logs data. Have you thought or explored the ways to distill the data to fit only necessary? Because no matter how this context window will grow, you will never catch all the logs. It's hard to store them sometimes.
Yeah, that's another good point. So for sure, as you said, this applies to medium to large organizations, not to small teams, for sure.
Mm-hmm.
What you mentioned about data, obviously we don't want to provide all the data, but at the same time, we have the flexibility up to a certain point where we don't need feature engineering, for example. We don't need data cleanup, but at least we need to choose which data. So if we're talking about commits, for example, it's easy. If we're talking about logs, then it becomes more complicated, like what data is relevant. And that depends on the system itself, on your company. For example, I know some companies that on Sentry, right, they have a proper setup where there is very little noise. So it becomes easy to know which like ingest all the sentry data that we get, for example, because it's small amount. But other companies, they have a lot of noise of sentry, so it might become too big. So it depends on the situation, how you can tweak it up. And the idea of this project is that actually you can play with it and you can decide what data to connect, how much of it, how frequent, and yeah, based on your situation, you can decide.
Yeah, just sort of bounce
Yes.
back. If you have a large scale team, how do you manage scale? Because you might have, let's say you stop the commits as you suggested. Or
Yes.
Delay is fine.
Yes.
Then you have 20,000 commits because you are Cisco or whatever, and it stops 2,000 commits per day. How do you mitigate false positives? Because it's a predictive, but it's not deterministic. You cannot have a probability of results.
Exactly.
So how do you mitigate that?
So ideally, this system becomes fully, like it would stop commits once we test it and we understand that it has a high level of accuracy. So we wouldn't launch it and it would block 2,000 commits and they are all false positives. But we are able to test it and understand once we get a good level of accuracy, then it makes sense.
But there is a class imbalance, right? You have always, even in the LLM, you have an imbalance of its knowledge on anomalies versus non-anomalies.
Exactly, but you can fine-tune it. You can make it learn, and it's
an issue class imbalance. You fine-tune on imbalanced data. You will have always more problems than things that never had a problem in the data set.
Not necessarily, because once you scope down what are the incidents, like what are the real positives, what are the real incidents, it becomes smarter. Like once the data is more accurate, it would be more accurate than LLM itself, right? Because it's trained.
Then you do more of that. And then you feed that up to the LLM.
But
you wash out all the knowledge he collected. No.
No. You select what data is.
I mean the AI, the way I see you.
Let's move a dialogue to someone else who want to have a
No,
dialogue.
but that's very interesting. We can continue the conversation. Please.
So just to understand, to prevent something from happening, right?
Yes.
In development pipeline, should we have like a pre-commit hook which will check the commit, or before the deployment? So when it's more,
So
on both places.
Yeah. That's up to discussion. In my opinion, it shouldn't be pre-commit hook because it's an expensive process overall.
So there shouldn't be like 200 commits to analyze the interoperability bunch.
Yeah. In his, I see your point. In his way, is talking about very big organizations where there are thousands of commits. But yeah, it shouldn't be pre-commit, right? It's something that in any case should have been prevented at code at review process, but maybe it slipped. And then at that point, the deployment, we catch it, but not before. So it's kind of last level of security. Not last, pre-last level of security.
Or it possible also fits to at the new pipeline stage.
Exactly.
Checked before, or like an environment in test AI environment, I don't know, or before the full general deployment also.
Yeah, the way I see is an intermediate stage, as you said. I wouldn't consider a new environment, but yeah.
But it kind of gets cheaper and cheaper. So the tendency still is for it becoming kind of a linter.
Not, a very smart linter though. Depends also which programming language you're working on. For example, we use JavaScript and not everything is coded by linter. I hate JavaScript. By the way, how many questions can we make more? Last one?
The last one. Yeah.
You.
Big smart.
I want to ask about if it uses unstructured data, but why not use the LLM to structure the data, use the traditional methods, and then after traditional methods use an ambient agent that receives, okay, this would be potential accident, and then like separate parts.
I really like this thought process, and that's definitely a possibility when you can do that though. For example, if we're talking about user bugs, like reports, you cannot really structure it, right? It's natural language per se. So how can you structure a report, a bug report?
You can distill it.
You can ask the LLM to structure it. You give him a JSON formatting that you define preemptively.
But it wouldn't be as effective as a large language model. That's the power of a large language
I
model.
mean, you can use the LLM to do the structuration. That's unstructured, the company that just got 40 million just lost that as a business.
I would disagree. That would be more effective. But yeah, that's of course different opinions. Yeah, there is no right. Yeah.
Okay. The stage is yeah.
We have something for the winner or no? A prize?
No, only
no.
for
Okay.
you. I'm
Only
sorry.
for you. Okay.
But you can give it away if you don't like it. This is the very first merge by DevOps AI Latvia.
Oh wow.
And it travels, the very first merge travels to Tallinn. So come closer. Do you hear it? Do you feel it?
Yes.
Thank you for coming, Stefano.
Thank you so much.
This is your gift. Yep, let's give a big applause. You need to remove your laptop, correct? And now we will continue with the lightning talk. But before I set up, you're a random person. Could you please join me? I got a task for you. So in a bag, there's chat happening and lots of things. And for example, the editor sent me a message that we could get banned basically on YouTube for using this live stream could be banned for using copyright. So now we'll try something. See, it says there's English error. You add here something like from which movie or whatever and try to go forward. Just right there your favorite movie and try to click done and make sound out of it. Let's see what happens. This is my first time trying that out. Generate. Does it work? It's generating it. Unexpected end of JSON input. And yeah, that's AI. Hello. What else do we know? This is Lightning Talk. This is we present. So it didn't work, yeah? Please wait. Music is being generated. Okay, we can wait a little. You tried to restart it, yeah? How long should it take? Music is being generated.
Maybe it's going to be ready by the end of my presentation.
It seems like it.
Also,
the mic. The mic. Yeah, we'll see. You need to just yeah. It can be.
Is it? Do you hear me? Yeah, cool. Okay.
Well, this thing is not working. This is not the presentation yet. I'm sorry, we can't trust AI. I'm sorry. It doesn't work. That AI thing doesn't work. But now then we move to, will you tell about yourself, Lauris?
Yeah. Actually, I've been asked, my name is Lauris Lauskis, and I've been asked in the first icebreaker, what's my connection with AI, with IT? And not really direct and long time, but meanwhile I've been working in Samsung Electronics Baltic CEO for some 5 years, and afterwards another 5 years as a partner and agency. But at some point my life moves over more to business mentoring and business trainings. And as Stefano mentioned, Robert Kiyosaki, it's actually one of my turning points as well, when I start to figure out about that mindset and that thinking of being of what things in life. So yeah, I got little, I hope we will build up some little sparkles here tonight. And yeah, I prepared short presentation. Actually, I was about to come with one slide, but then I was thinking I need to be more formal, so I build up 14 slides. So first one is over. That's good. So yeah. By the way, who thinks that aviation is sexy?
Aviation. Yeah.
Yeah. Is it cool? Nice one. Yeah, we will talk a little bit about aviation, but not about sex tonight. So, sorry. Yeah, but two main topics we will cover tonight is real LBS and cargo calls. Does anyone share common with them? Does anyone care about them? No. Yeah, cool, great. At least someone will support me. Because I was digging out some also about the mindsets and thinkings. Actually, I heard from Stefano that earlier there was a topic about how to prevent some mistakes and some incidents. In my case, I was predicting ahead what's happened when something happened, what to do and how to avoid it. And now we will see how it looks in a real life. This is a structure of World War II bomber, which came back from battles, and they figure out this one still arrives and it's still alive. And they were thinking, where do we need to add some more armor, or what we need to do some updates or upgrades with that to protect our planes. So these ones who came back, as we see, with all these shots. And Hungarian mathematic Abraham Lab, he came up with a theory that there might be some logical error regarding these ones. They came back with these shots. So they first imagination was let's build up stronger those parts which are already shot it through, but they came back with those ones. And here we came down to that theory which comes to not protect those things. So the mathematical theory and the mindset in general here is those who came back, they were able to arrive with all these shots. Those who didn't came back with shots in motor, in engines, in some propeller parts, they didn't come back. So they got this logical error where they take not whole data, which should be 100% of all these planes being off to go and who came back. So those ones who've been shuttered in those specific points, they didn't come back. So they start to build up and they start to protect those parts which are very important, and they still came back with all these shuttered wings and other parts, but they still survive and came back. And this is about also in a life and in a business, and I think especially in IT as well, when we have some logical errors where we follow something which is some data which is not complete picture, and we start to go somewhere, and at some point we find here we got a mistake, it doesn't work. Why it doesn't work? Because it might come with some error. And another part which is also connected with this story is let's fly over half opposite side of the world is the Pacific Ocean, also the World War II. And there was a cargo code which was founded in early 50s. When the war time happens, there was lots of airports and different kind of vessels in this particular one picture is from New Guinea, and now in many of those islands there was lots of descents and all this kind of stuff. So these people, they got some benefits from those that big giants on iron planes. They came over and they often give them some gifts and stuff, so they were happy. But when the war was over, all these guys flew away and nothing's really happened. And what these guys started to do is they started to build up some cargo cult relics and start price on them and ask for gods to come back and give them gifts again. And here we got that mind point, which is a form without function. People sometimes make something which makes some form but doesn't give a real structure, or surface without substance. Yeah, and it's again goes that way, that we follow something which doesn't really work. It's some surface or some imaginary, but it doesn't give us real real result. By the way, that's how the real bombers looks like, and that one is a B-52, quite big and expensive machine. So, but these guys still try to attract something comes and works for them, and yeah. And I was thinking out about this topic a little bit deeper, and I found there's lots of many authors mention there are many stories of similar accomplices, and I do believe lots of them can build up something or find out in your experience, business or private life, something where we follow some fake gurus or some fake idols, yeah, and it doesn't take us the right point where we want to go. And yeah, there are lots of technologies, and there are a group of people who are more interested in cargo clothing than the actual understanding why, when, or how it is approached. Yes, and bottom line of all this short slide over almost whole planet is don't focus on the winner, study the missing data, which gives you a full picture, and you can get to the right result. And yeah, imitation without understanding leads to failure as well. That's my Lightning talk. Thank you, Aldis, for welcoming me and speak in an audience for a while, but I'm happy to be here. Thank you, Aldis.
What? Yeah, that's the second one.
Second
What does billionairemind.pro do?
Yes, I do the Billionaire Mind is business simulation trainings where we open potential and can in a safe environment can play around the businesses, because in real life the business mistakes cost a lot. It's financial, emotional, sometimes big losses. In this case, we play around those things and can give open potential and of businesses, and sometimes actually in cases the people afterwards they said, "Oh, I got this my pattern here, not in a real life." Yeah? It's better to go for a boxing ring with some virtual partner, not a real professional boxer. So yeah, if everyone's interested, and welcome. I'm in Latvia, but also work online. Thank you all this once again, and I will drink coffee tomorrow morning.
Yeah, thank you. And great answer. For that, you get also a box which comes with
a bonnet.
Alrighty, so let's start back up after the break with a little game. So, if you, well, I'll tell you that on the next slide. But if you paid attention to the event poster and the description, then you should be good to go, because anything in the presentation, in the quiz, will be from the intro slides and from the poster as well. So let's see how many people we have who have joined. Yeah, either scan the QR code or go to menti.com and enter the code. Wait a bit for people to join. And there's going to be a small prize for the winner of the.
Oh yeah, let's join.
Yes. So. And someone left instantly. Prizes is not enough. Okay, maybe let's say 20 seconds to join for the last people, and then we can start. This is not getting less. All right, I think we get. Okay, so how the game works, you already played this once with the first speaker. First question, which event number is it today? 24. Very good. Okay, question number 2. Who are today's speakers? Seven votes in. Okay. There was a poster in the beginning of it. Okay. Let's continue. How many core members are there in DevOps AI Latvia?
Where's and a half?
Well, I took it from the slide where there was all of us, and we have like half as well.
I think that's okay.
8, correct. Or okay, at least some diversity in responses. Question 4. What is the name of the YouTube channel this event is streamed on right now?
I thought it was UP.
Yes, DevOps AI Latvia.
Oh, the last name is very good.
Help some friends. So it was you, I see.
No.
What animal is in the logo of DevOps AI Latvia?
You use AI to generate this.
Well, part of it, when I ran out of questions that I could think of. It's not a horse, it's a unicorn. It has a little horn. So there's gonna be 10 questions. After 5 questions, that's a leaderboard. So Lex is the fastest and the high scores for now. All right, let's continue. Who are the sponsors and partners for this event?
Tricky one.
Okay, that's surprising.
Good brand.
Means you can sell some model rooms.
So, who is giving the lightning talk you just had? OEB wasn't here today. Okay. Where to register for future events?
Is there a prize for the all answers wrong? I think someone's really trying.
Well, I can give you a beer because you deserve it for that, for getting everyone wrong. So, question 9, almost done.
What should you check out besides the event? I think the winner of the quiz will be just the one person who's the fastest one, probably. It's kind of easy.
More people trying to get the beer.
Maybe that's the real prize is the beer. So, last question. Who would you want to share a pizza with? Stefano, Edgars, or Lauris?
Italian pizza with me.
Three questions, all of them were wrong. All right, and that is all of the questions, and let's see who is our winner. And it's Earthman. Please, whoever Earthman is, please approach me then after the second talk for your prize. And I will look up who got the least points, and then that person will get the beer, okay?
Can't see it there.
In the full export, can't you? Really?
No, yeah, I tried.
Oh,
Years
man.
ago, it's not.
Well, then triple A gets, from top 10, gets the consolation prize. All right, so that was for the quiz. Back to you.
Did someone get the prize? I just missed.
No, I don't think afterwards. Or who is
when
Earthman? You should probably be in this room, I think.
Well, there could be someone online theoretically.
Well, approach me afterwards then for the prize. If you don't want to win it from anyone.
Jā, tas ir online.
Oh, okay.
Would love to we continue with the 15-minute break. No, joking. Okay. Second icebreaker. Find another person who you don't know. This time I'm literally positive things about your first impression about each other. Recheck that you remember each other's names. Go! Tell me the name of the other person. Nice. Well done. Well done. Applause to yourself. Who has been to Riga Tech Dinner? At least once. A few people. Who has no idea what the Riga Tech Dinner is? Quite a few people. So it's an event where we meet, where we listen to very interesting people from tech. It doesn't mean that they are experts in AI or that they have done any coding for the last 10 years. Typically, those are people who have done something useful with their lives. So they get to be on a poster. And then in February 25th, we'll have who knows betters, like personally, a few. So this is a chance to meet him, talk with him, probably talk about his work last year's experience. About that. And then Carlos Vilcinch, who I personally don't know yet. I will meet him at the event from LMT, Head of Systems Integration Business Department. So find the information in a meetup. It's actually in the same place where you registered for this event, in the same group. And there's one thing, if you're interested in the event, there is a new WhatsApp group where you will get future updates. So feel free to scan it, join the WhatsApp group if you want to. If you don't want to, don't do it. Does it work? Yes. Okay. When people hear that it works, then phones go up. That's an interesting reaction. Okay. All right. If you miss it, contact me personally. I'll share the link with you. Then a few people keep asking, so how are you different from Dev Club? I feel you can resonate. We are different, no doubt about that, but we are great friends. You can see it on our website that we are great friends with Edgars Ruņģis and the whole crew. And then this Thursday, there's going to be a pretty interesting event, and I personally wasn't planning to go. Kind of hardware, that's not my thing. Then someone asked me, and I looked at these names, and these are three more people who have figured out what to do with their lives. So yeah, I believe it's going to be a pretty interesting event. Yeah, but then we move back to second part. And so I tried another AI music generation app. Don't try this one. It doesn't let you to pick anything, but it generated a sound. That's pretty loud. Okay. That's your intro song.
Oh, thanks. We're actually happy to do the vector embeddings for this music and see what is the similarity for that particular track. But let's see. Yeah, so, Labatar. Hello, everyone. Actually, I saw on the quiz that 4 people want to share pizza with me tonight. So I'm really happy to do it. Just after my presentation, reach me out and we can have some discussions about pizza, beer, or whatever topic you would like me to have. That's not like the first slide. Okay, that's good. And this is the
short one, the same one.
This is the right one.
Yeah.
Okay, cool. So I need to get back. Oh no, it's sorry for that mess. So I need.
You can use the laptop as well.
Yeah. Oh, okay. Fine. Yeah. So actually, this is my first time when I'm presenting so late, and I'm really happy to see so many people after the free pizza and the beer, because usually this is not the case when I'm presenting during daytime. Then I remember many cases when after the free lunch, only a few people actually showed up. So I think this community in that sense is really, really different, and I'm happy to be part of this community today. And my name is Edgars Ruņģis, and today I'll be talking about this AI vector search in the latest release of Oracle Database 23 AI. So in the first part, I will be discussing why do we need actually this kind of vectors and vector search. Then we're gonna have a look into the more details. What are those vectors about? And last but not least, I will be discussing how actually to use this vector search inside the database, looking into the more on the technology side. Just a couple of words about myself. I have been doing IT over like 25 years. Started as a Java developer, then went through different database development roles. So databases are still my passion. And I would say last 5-7 years, I'm doing mostly doing cloud engagements, and lately mostly the Oracle cloud engagements. And actually, I just wanted to start my presentation with one question, but just be open, direct, and honest. When I say the Oracle, what does come as a first thing in your mind?
Java.
Java database.
Not in Latvia.
Legacy.
Not in Latvia. Good point. Actually, I was expecting like old dinosaur, dumb, expensive, and this kind of stuff. But happy to hear that was a quite positive feedback actually. And yeah, we are still doing the databases, and this is, I would say, our core product. And these days we are actually one of those 4 cloud superscalers as well. And it's not that expensive, I would say, anymore on the cloud. But yeah, I will be talking about, of course, the IE vector search, the Oracle database. But if you guys are like using Postgres or anything else, you're gonna find a lot of like similar stuff. And this is gonna be more about like learning what is this AI vector search, maybe not that much about the Oracle database itself. So yeah, so let's get started. So relational databases in general, I think have been around over 30 years, and mostly the way actually we kind of like traditionally did those searches was like doing some queries, like finding revenue by the products and this kind of like stuff. How actually this is how the relational database started. So we want to have those relations, we want to write some queries, and we wanted to get back some value-based data, or so-called value searches by dimensions, by the facts, and that's like pretty simple thing we still are doing today. But what lately we have seen that there are really like a growing volumes of unstructured data which are being stored into the even like relational databases, unstructured data like documents, pictures, videos, and there is one, or there has been actually a pretty big challenge how actually we enable the semantic search over this kind of unstructured data, because as you know, those of you who have been working with like any of relational databases, you usually can do some phrase-based or keyword searches. There are a number of sophistications over those search technologies, but still, if you want to do this kind of semantic search, it's never been like really easy, especially inside relational databases, which are still a lot around these days. And the way actually, so the question is, how do we enable this kind of semantic search? By the way, before I get to this kind of semantic, does anyone know what is the semantic search in general? Can you just, or is there anyone who doesn't really know what it means? Yeah, it's searching by meaning. Just let me give you a very simple example. For instance, let's imagine you have a database which contains the documents about the wildlife. And you would like to search for the big animals. So you do the search inside the database, big animals, and if you don't use the semantic search, what do you think? What you're going to get back as a response from the database? You're going to get a lot of documents with the keyword big animals. If you have some like synonyms and this kind of stuff, you might get something else, but basically you're going to get a list of documents which includes the keyword big animals. But if you have enabled the semantic search, you're going to get the documents with giraffes, elephants. Can you help me with big elements? Whales. Perfect. Yeah, exactly. So you're going to get like a full bunch of those big animals, which means that the semantic search actually understands the connection between those words. And this is what is the semantic search about. And we're going to be talking, what do we really need to do to enable the semantic search on our database data? And it's not only about the database data, to be honest. Today already Stefano mentioned a little bit this RAG kind of pipelines, which like many companies are doing today. And this is one of the prerequisites. You need to vectorize your data before you will be able to do those so-called semantic search. And that's what the semantic search is about. Basically, yeah, you need to vectorize the data. And so what does it mean, vectorize your existing data, especially if you talk about the databases? Then basically, what is the vector? That's the first thing. So technically, the vector actually looks like a sequence of numbers. So we sometimes call it like dimensions. And as on this slide, it kind of captures these important features of the data, or I would say it represents the semantic content of the data. If you talk about data, these are like pictures, documents, video, but in general, the vector is just a sequence of the data and nothing more. And let me just give you an example. So let's say we want to vectorize our support incidents. So incidents is quite a popular term tonight. So let's try to vectorize our support incidents. So basically, yeah, the incident is what is usually is having like a couple of the features. It doesn't matter. It's really simplification of vectorizing this kind of data. But what we do basically, when we vectorize the data, we got a sequence of the numbers which kind of represents the semantic meaning of those support incidents. And I should just get me back to the previous slide. Sorry. And the question is, how do we do this? How do we create those embeddings, or how do we vectorize the data? So basically, what we are doing, actually, we are just running this data through those AI deep learning models known as embedding models. So you will hear a lot that creating embeddings. So basically, it means vectorizing the data. So creating embeddings means that we take the document, extract the text from the document, and then we run through this deep learning model, which is known as embedding models, and then we get this sequence of the numbers, which we call the vector, and those numbers basically are dimensions of our vector. And this is just a representation, like a very kind of not realistic, because usually we have like hundreds of those dimensions, even of this kind of like simple support incident ticket. But basically, that's the way how we kind of are vectorizing our support incidents. We are creating those embeddings or the vectors. And then the question is, if you want to find the similar support incidents, what does it really mean? And if we would, let's say, represent those vectors in 2 dimensions, which is never the case because we have hundreds and even more dimensions. So if you want to represent those vectors in 2 dimensions, it means that the similar incidents actually would have that they would be located in our 2-dimensional space the closest to each other. And this is exactly what actually is like what it means, like similar vectors. They are just closer together. So those 2 ones are similar, which are about laptops running slow, and that one is not similar because just the distance between those 2, between this group and this group, is much longer. So what actually we need to do, if we do the semantic search, it means that we need to measure the distance between our vectors. And what it technically means. So if you have 2 vectors, there are many, let's say, mathematical distance formulas how you can do it, like Euclidean square or cosinus, and many more actually. So it really depends how you what type of let's say data you did, for what kind of data you did those vector embeddings. For instance, for text documents, maybe much more efficient would be the cosinus distance metric. For images, Euclidean squared metric would be the best. But basically, yeah, if you know you search like similar incident tickets which are vectorized, then basically your similar means the distance between those vectors which are similar. So they are the closest ones. If as you remember, if we represent this in 2-dimensional space, but usually, as I said, vectors are having hundreds of dimensions, not just only two dimensions. And the same applies to the text information and images. And this is what I discussed at the beginning. So we were like discussing about the big animals, how to find the big animals. So if you do the semantic search on the information which has been vectorized, then basically, if I all the animals will be, let's say, in this kind of group, again in kind of this fake 2-dimensional space. The same is the fruit and states. If you talk about the states of the United States, yeah. So it just again, it's about the distance across the vectors, and this is the way how actually this vector search works. We are just need to find the closest vector. Let's say if you are, I know, like doing the animal search, then we know that this kind of semantic meaning will be already there because of those connections across those all those words in this particular example. And yeah, if you do the vectorize the tiger, it's gonna go in the same group because it's a big animal. So that's a bit kind of theoretical part, maybe a bit boring for many of you who already are familiar with the vectors and vector search. Then let's have a look how actually we can use this vector search. So as I said already many times, so basically the vector search enables this kind of like semantic search. And the best part, if you do this on a relational database, we actually can combine our relational data with our vectorized data. And I don't know how many of you have heard of this kind of like, I would say it's more like a marketing. The Oracle usually talks about the converged database. What does it mean? That that basically we do support like a lot of data types you can store and process in our database, like JSON, relational, vector, graph, and many more. And basically it means that you can actually combine those different kind of data types in the same SQL query. For instance, if you want your JSON document across with a new vector data type and relational data. So that's kind of like the benefit of this approach. Sometimes yes, sometimes not. But what really we did to enable this vector search. So first of all, yeah, we added new vector data type inside the database. We extended a little bit SQL syntax. And we introduced those new type of indexes because you need to understand that searching multidimensional vectors are very expensive in terms of computational power. So to speed this up, of course, we need some kind of specific indexes for this new data type. And this is with every database which supports vector data types, not only with the Oracle. You need a special type of indexes to deal with this. So how Oracle AI vector search works. So basically, as already discussed in the beginning, so let's say you want to find a picture which is similar to your house. So what you're going to be doing, you take your picture, you create the embedding of your picture. So basically, you just run this picture through this embedding model, the same, which has been used to embed all the pictures inside the database into the vector format. And then, yeah, so this vector embedding is just you are searching for the closest distance of your vector with the vectors of the pictures which are vectorized as well. And that's always, you do the same for the text or whatever. So before you do the search or semantic search, you vectorize this initial prompt or initial query, the information you are looking for, like this could be, as I said, image or a document, and then you do the search and find the closest vectors in terms of the distance. And basically, let's just quickly go through all this kind of process that we need to, first of all, we need to generate, or we need to vectorize our existing data. So we sometimes call it like generate vector embeddings from our unstructured data. Then we need to store those embeddings into this new vector data type. We need to build this new index, and then we can do basically the vector search by using the standard SQL language. I have been like a database guy. I love SQL, still love SQL. Even I have been working a lot with document databases as well. And actually, my free time, I'm doing some Python and large language models, as everyone does today, I believe. But SQL is still kind of my love, I would say. Yeah. So there's a new vector embedding function which actually generates those vectors. So, but the first thing what we need to do, and there are like two ways how we can do the embeddings. You can imagine that we can take this information out of relational database to some like Python middleware. We can do the embeddings and then store back to our vector database. That's one approach. Another approach that we just load this embedding model inside the database. And then, of course, we run those or create those embeddings inside the database without this information does not need to leave the database to get those embeddings. So, and this is something what really a lot of customers prefer because especially if you have a really big databases which you want to vectorize, it's much more efficient than getting data out, vectorizing and storing back. So yeah, that's what we do. We just load this embedding model, which should be in the ONIX format. We load it inside the database, and then we just, this is the way how we actually are generating the embeddings. And then, of course, we need to store back into the database if you want to do. But there is another approach. It's a very, very simple Python code, basically, what I just tried this morning. So if you are using some Python, like, I don't know, like, how many of you are like familiar with Python? I believe most of you. Yeah. So guys, you can read this. It's a very simple one. We are just loading and some Hugging Face model, exporting to the ONIX format. Then we are connecting to the database, reading this model, which we set in file system. We are reading and then exporting back to the database. So that's kind of another way we're doing, because in this case, we are using this Oracle machine learning for Python library. So that's something you can actually utilize for this kind of use case as well. If you don't want to do this kind of PL/SQL right way, which is the Oracle's database kind of programming language. So you can, of course, load this model into database this way as well. Storing the vectors. So we introduced this new vector data type. So it's called vector. And there's like two optional parameters, like dimensions and format. Currently, we support only like three those dimensional values for the format. More are coming, but you need to realize that if you specify those parameters, the problem is that those embedding models change over time, and it's much better or recommended just to specify the vector without any formatting for the dimensions and format, because then you are kind of free to change those embedding models, and it would not cause any problems in your schema. So I would always go with this kind of simpler option. But of course, you can fine tune with those two parameters as well. Some vector operations. So basically, yeah, what we can do, we can. There are like two functions. With the one is which converts a string representing an array of the vector dimensions into the native vector format, and then we can store it, or we can do it all the way actually around as well if needed. And sometimes actually there are some use cases what I have seen that customers want to load like hundreds of millions of vectors inside the database. And then of course there needs to be some kind of fast way of doing by eliminating some maybe middleware for doing that one. And we have this kind of load type of utility which has been around like for ages, which you can actually utilize loading do this kind of like bulk loading inside the database of your vectorized data. Indexes, that's something which is very important actually, because as I said, like if you are computing the distance across the vectors, it's a very, very computationally intensive task. And by using the indexes, we can, of course, minimize this and improve the performance, the search performance for our vectors. And that's why we introduced like two types of the vector indexes. Again, these are very similar for every database, not only for the Oracle. If you talk about vector data types, the first one is what is called the neighbor graph vector index, which is only in memory. And basically, I like this kind of way of simplification because basically what it means in this kind of graph, what it means closest vectors for the vector number one, the closest one is 2 and 3. So this distance, if it's close enough, so we use the edges which are connected, and then you can imagine that you can very easy or in a fast way actually to do those similarity searches across your vectors. But that would not work most probably if you're going to have a really big database, like hundreds maybe of even terabytes and 100 million of the rows. Then you need something which is not because it's not going to fit just in the memory of your database machine. And then we have this like neighbor partition vector where the vectors actually are being partitioned by this proximity. And this is like really kind of for scale up situations and scale out where you are dealing with a really big databases. But I think for most of you, most probably this one would really do the stuff. And there are maybe like, I'm not going to go into details, but there are some like fine tuning you can do with those indexes. So when you're creating the index, you specify which one you do this in memory or this like using this kind of partitioning approach. And then there is a new parameter, target accuracy, because you need to understand that there is some kind of default value like 95 or something, but you need to understand if you really want to get up to like 100% accuracy in your search results when you do this when you do this kind of similarity search, it's gonna cost you a lot of computer resources. So that's why you usually need to balance this. Like 95 means that 95 will be like really those vectors will be like close to the one you are searching for, but those 5% might be a bit kind of loose coupled in that sense, you know. So that's it is something you can fine tune actually, but like the recommendation is like 90, 95 is really like a good balance. And last but not least, I think the most important part there, how do you actually do those searches over the vectorized data by using the SQL? So we have this new function, which is called vector distance. So which basically means how close. So we can, you will see later, that's kind of measuring the distance across those vectors. And then we, of course, provide this distance metric, which is default one is Euclidean. We can have some cosine similarity as well and dot product if you want. And there is just a very simple example how you do it. So basically, you have this new approximate function, so which allows you to find the most closest vectors. So in this case, basically what we do, we find the top 5 customers by similarity with this search photo vector. So we vectorize this photo and we just find this kind of proximity, the closest 5 customers. And that's very simple, you know, it's just one very simple query how you can do this approximate type of like similarity search for the vectorized data. And there is, of course, you can again play around this target accuracy on the SQL level as well. If you want to override the one which you specified on the index side, I mean, again, that's for simplicity. Usually, you leave the default one, and I'm not gonna most probably play around this. But you just see that you can really do some fine tuning even on the vector databases, which is really cool. And this is just a very simple query how you are combining the relational data with the vector. So basically, find top 5 customers by similarity with a search photo vector, let's say with similar houses or similar faces maybe, who live in the San Francisco and who have credit limits greater than 10K based on their status. Very interesting query, I must say, but whatever. So yeah, that's basically, you know, the way how you again can combine this relational data or can combine actually some JSON data as well. If you have a JSON data inside database with those vectorized data, and again, it's a very simple SQL query to get those the top 5 customers with the similar photos, whatever this photo is about. And if you talk particularly about Oracle database, then yeah, this vector search, of course, is integrated in all the components. I'm not going to go into the details. I think it's not that interesting. Of course, you can do this transparent data encryption on your vector data if you want. You can do the partitioning, parallel execution for the SQL queries on the very big data sets, and many more things. So yeah, the four key takeaways for my presentation. Yeah, so there is a new vector data type for storing the vectors, as we discussed. Is a bit extended SQL syntax to do this similarity search, which you remember. And there are some new vector indexes, which is just for tuning your performance. And basically, you would have the same for any database, like Postgres, for instance, is having pretty much the same kind of technology. I'm going to discuss which is better, this one or that one. But like from the information I'm discussing today, it's not that much different, for instance, in the Postgres as well. Where to use the vector search? There are many use cases, but we already discussed today that remember that Stefano, can you help me a little bit? Is he still around?
Yeah, I'm here.
Oh, so remind me, what was the RAG? So you got a very good definition of the RAG.
Yeah, retrieval augmented generation is we augment the prompt with related data based on what we originally asked.
Exactly. So we need to provide a context for this large language model. And to find the context, what we do, actually, we search inside our organizational databases or data sources where the data has been vectorized, including relational databases. So once we are vectorized, we get to our initial prompt, let's say top 5 similarity searches, and then we just provide this as a context to our initial prompt and send to the large language model. So this is how it works, and that's I've seen this like many use cases around this, how actually this vector search is being used. Of course, you can use, for this purpose, you can use some dedicated vector databases, open source databases as well. I think the key benefit here is that if you have already a lot of data inside Oracle database, then it really is kind of you have this benefit of combining this relational data with the vector search. And if you want to have your hands dirty on this, actually you even don't need any like environment. Just go to the labs, search for the AI vector search, and start any of those workshops that Oracle will provide you with the environment, and you can just play around and see what is this really about. So I think we will share this presentation with you, and you're going to have a link, and you can try. Yeah, there is something for free, even talking about the Oracle, so you can still try some stuff from the Oracle side. So yeah, we have this plenty of like free database on this free Oracle GitHub, for instance, or Cloud Oracle Tom free, and many more. So of course we do provide a free database. We do provide free databases on the containers, like autonomous database, which you can use for development purposes. And there's just a couple of links which I think you will share with my presentation, and you will be able to see. And there is just one little spelling error. I realized if you're going to be sending me the email to this email address with this L at the end, I'm not going to get anything from you. So no any pizza invitations to that email, just without the L. Yeah. Okay, guys, that was a very quick overview about the vector search. Hopefully somebody of you find it a bit useful. And yeah, if you have any questions, then let's. It's not just only one question.
Wait,
Yeah.
I'll start with a question because I can. So let's say I have my in-house infra. I have Oracle database running there from 2015. 2015.
Sounds like
I'm sitting here. I'm like, whoa! This I should try that out. What do? I have it on-prem run in 2015. We're like, yeah, we're not paying for your stuff for a few years already. It runs, you know. So what do I do?
Because customers doesn't like this kind of use case, I would say, because you need to upgrade to the latest release of Oracle Database 20 AI. But those ones who are having the support contract, they can do it like easy. The ones who doesn't know, guys, just move to the cloud. It's available for like, I don't know, like €100 per month or something, you know, this technology. So,
okay. But then do I need to add some add-ins something?
No.
It's native now.
It's native, a part of any Oracle Database edition, even like free edition, standard edition, enterprise edition. So it's just native.
Okay, just upgrade to the latest version and you get it for free.
Yes.
Yes. Okay.
I mean,
questions.
Yeah, go on, guys. I don't know who.
And you showed that simplified syntax for defining vector column without the dimensions. So it means you can mix different dimensions within the same column.
Exactly.
And how will indexes and search work in that case?
That's not the problem. I mean, because what you do usually, you have one column for your vector data, where you can specify those parameters. So you just leave it as a vector data type. And then you do of course, the embeddings, you create embeddings, you store there. And then when you do the search, of course, you need to assume that you're going to be doing search with the same distance metric, like Euclidean or whatever, across all these columns, you know. So when you create embeddings, it doesn't matter what kind of algorithm for calculating distances you're going to be using. But at the moment when you do the search, of course, you understand that when you do this distance search, it goes across all the rows of this particular table where you are having those embeddings, and it doesn't really influence the indexing in that sense.
Yeah, but let's say I have a column and I have data that weighted by 2 embedded models, one with 50 dimensions and one with 100. And then I
It doesn't matter. Yeah, it doesn't matter.
I have some input for which I get embedded with the 50.
Yeah, you need to just, yeah, that's a very good question. But there's one thing, but you of course you need to, so let's say, if you look at this column which stores the embeddings, so what is very important that this column actually is being, those embeddings is being created by the same embedding model. You know, not like every row is different model, then you're not gonna be able actually to do any distance search. And what usually people do, so you have a relational, you might have one column which is using the Oracle text and storing some documents, for instance, and then you might even, of course, in real life, you might even, as a first step, you will do some chunks, and then you vectorize those chunks, which you might end up with another table which will have those chunks vectorized. So it really depends on the use case.
So then I have to still merge the embeddings because the database will
yes. But this was a very good point. Yeah.
So there will be some discretional column to choose the right embedding, choose the rows I will search after. Yes.
Yes. If I understand correctly. Yeah. Was some more questions, guys? I'm really thirsty. I need a beer.
Just the in-memory aspect, right? So one of the selling points is the speed of retrieval. Imagine, because vector databases are notoriously slow. So now, is it a tier storage? How do you materialize that?
Yes, exactly. In Oracle database, you can really do That's a very good question. You can. I remember you were doing very good questions even with the previous one. Yeah, in a Oracle database, you can really do this kind of tiered storage. So you can even decide that you want to be. If you talk about those indexes which are being placed on the storage, this is those partitioned indexes. You can even have different partitions of those indexes on different storage tiers if you want. So it's about the tuning, fine-tuning, of course.
So freshness is what on the retrieval? So freshness as in the time of write versus, or compared to the time of read, all end-to-end, right? That's what you want when you do real-time systems.
Yes.
So if you do an in-memory system like this, what matters is at the moment of a new information that gets in, how fast can I get it out? And can I get this embedding or ANN or KNN or whatever? So what's the freshness on that? And is it materialized in our offline storage?
I mean, that's, it's, I got your point, yeah. So basically, the Oracle database, whenever you do this, like you are writing the information inside the database and, so your question is that if you write something, you are like, your concern is that this information might not be indexed in a real time.
Well, if you do the in-memory aspect, you can retrieve it super fast, right?
Yes.
But if new information comes, if you can't write it super fast.
Yeah, I understand. There was actually, I did discuss, if I go back to this index slide, you would see actually there are many more parameters for the fine-tuning the indexes. And one of those actually is exactly addressing your question. But I haven't, to be honest, I haven't explored that much yet, but this was a very good question. So I can get back to you with some more details. Pizza, sharing pizza. Sure. Yeah, next question.
About the models suggested or in production which are in use, are there specific use cases? For example, the one you showed that is top of the Hugging Face as general model, are there like other models that are used in specially?
No, we're not restricting as far as this model is being imported inside a database in the Onyx format. So you can use any model. You can even have your own model, or you can find some model and then upload in the database and use it. We don't have any restrictions.
Yeah, I mean from like production examples or what you have experienced, like are there any models with specific use cases? I think some model is better for images.
Yes, absolutely. Yeah, I mean, it's not better for image, but for image you will definitely use different model, embedding model than for your documents or text information. That's absolutely true. Yeah, and because which one? There's no really like one kind of use case, because customers, what I have seen, they do a lot of testings regarding those models. They fine-tune those models and then they just upload to the database. It really depends on the data you're going to be embedding. So, yeah.
I have just a comment.
I think I just want that everyone, I want to discover this courage everyone to use these systems, because if you have vectorization, this is like an abstraction form, yes? This is like a little bit a black box. You actually don't know what's behind it. And then you have a black box, which is actually the model which you are using, like for example, if it's ChatGPT, you don't really know how it's actually what it's doing behind the scene, yes? And then if you don't understand the data, what you're actually feeding in, you just, for example, okay, I have the database, just let's vectorize it and then just look for some results. It will, you will have no understanding, no clue, like, is the result correct or not correct?
Yeah.
That's actually,
It's a good comment, because of course I was doing a lot of simplifications during my presentation, you know, because as you guys know, everything works on the PowerPoints, like 100%, you know, perfectly. But of course, in real life, you need to do a lot of preparation to decide about which model you're going to be using, for instance, you know, which is based on your data set, and what's going to be the goal, how you're going to be actually using this vectorized data later. So yeah, I would not maybe agree as much on this black box, because vectorizing is pretty much like the same as any technology. Like, you get the vector, you store in the database, and you then do this kind of distance search. It's the implementation, of course, is different for free database, but say it's like a black box. But there are no, like, in that sense, maybe there are not that many like open standards at the moment, you know, especially for the SQL syntax, for instance, as well. So it's still kind of developing in that sense. Yes, so Oracle maybe did this way, Postgres did a bit different way, especially talking about the SQL.
For example, you have your NoSQL database data, then you have, for example, video data, and then you have two vectors, images, data, text, and videos, and speech, and then can you really compare these vectors in any form? Like, can you relate them together? Like, do you have them understanding?
There are different models, yeah, exactly. There can be different models for all those data, and then you do this, you know, this standard math of finding out the distance between those vectors.
So there is models, which it's a set of models. You have model to get the text vector. You have the model to get the picture vector, video vector, and these models are trained to produce exactly the same vectors. So if you have text about cat, the picture which perfectly is described by this text, and the video which is perfectly described by this text, your vectors will be almost identical.
Yes, that's a good point.
Just to seek this kind of model or train yourself.
Just for example, if I'm using
multimodality in research.
So this, yeah, this is becoming a discussion, which is great, but we will continue those in the other room. Right now, we are saying big thank you to Edgar. The first batch. It's still the first one.
Yeah, but there was discussion on the quiz, horse or unicorn.
And what do you think?
Definitely unicorn, but you know, after maybe 2 or 3 beers, it might change.
Yeah.
You know?
So the whole idea is that actually, if you remember the Agile, the DevOps and Agile logo, it was just a unicorn. So this one is
it's a beautiful anyway.
You see, it's a robo unicorn. So this is the DevOps and AI Latvia symbol
beautiful.
now.
Thank you very much.
Thank you, Edgar. And the box. Great, thank you.
Does the robo unicorn also imply that we all will be back?
Back where?
We will be back, not I will be back. But
okay.
We all will be back if that's what you're implying for. No, that went too dark. Anyhow, so big thanks to. In many ways, this event is possible. Specifically tonight, this event is possible thanks to Arvato. So thanks to Arvato. We're definitely looking for more sponsors. Yeah, okay. And then kind of thanks to Arvato, and in a way, just because we're so light-minded, there's gonna be a surprise. Do you see it? Do you see it? Yeah, this was not planned, but this is in part 3. There's like hot pizzas are slowly arriving to the back room, but the part 3, quick explanation about that will follow in a moment, because one thing which we want to get from you right now, please, right now, we want to get your feedbacks about this event. This is mandatory for everyone. Please do send your feedbacks.
Will you check before giving us access to pizza?
Yes, you will need to scan that you have done it. Once you complete this, you will get a barcode which we will scan for getting pizza. I never lie, I just get confused.
8 slices or 12 slices?
Slices?
Of pizza. How much can you eat?
It depends how much you can grab.
Fast.
Yeah, please do provide us feedback. Please do provide us feedback on meetup.com platform as well, because that one is public, kinda, and it matters. But this one is not public. This one is truly for us to see how we did with the event. Well, we're sitting in silence. Nadia, how do you feel about the event? No one knows that, but Nadia is kind of taking care of the whole event. She's sitting in the middle. Did we do okay?
Great.
Thank you.
I'm trying to impact feedback.
Okay. All right. I hope you, if you haven't finished it, please do in whatever. And then quick explanation, kind of what's gonna happen. A few people know how it works, but in short, we get to the other room. We still have a couple of hours to go if we want to. I don't know, depends on Andrei in a way. But those who are interested in let's say some deep talk, in some deep conversations, join me on the sofa, just behind this wall. The rest, you're so dumb. You have naughty thoughts, Andres. Yeah, and I'll explain you more what's gonna happen there. The rest, enjoy hopefully some pizza, a few more beers. Oh, pizza. But it's coming, it's coming. And I hope you enjoyed the evening. Thank you.
Thank you.
But pizza is coming, it was not a joke.